So today we're going to be talking about dimensional analysis. And dimensional analysis is just a fancy way of saying that we're going to be doing a whole bunch of problems that involve converting between two or more different units of measurement. So you probably saw this back in middle school when we were doing problems where you're going from like feet to kilometers or milliliters to gallons. Every time we do a problem like this, there are going to be two steps, and you want to make sure you write these down because we're going to need them when we work through some problems in a minute. We're going to want to identify what we are given in the problem and what we want to find in the problem. And we're going to write both of these down so we make sure we know what we're doing. The other thing we're going to need are what we call unit factors. These are factors where both sides are equal but in different units. So things like the fact that 1 foot equals 12 inches. They both represent the same distance, but they're in different units, so I can use them to convert. Another example you might not be as familiar with is 500 milliliters equals 16.9 fluid ounces. You may recognize that because it's on the side of a whole bunch of half-liter bottles. So the easiest way to explain what we're doing with this is to actually try some problems. So let's look at a couple. So the first problem, and as you can see, dimensional analysis can be really useful in everyday life. This is actually something I had to do. But dimensional analysis can also be really useful when it comes to doing various kinds of science problems. You can actually get most of the way through even advanced placement chemistry just knowing how to do dimensional analysis well. So let's read through our problem. We want to figure out what we're given and figure out what we want. So here in this problem, I'm reading through. I need to add 0.5 cups of peanut butter to a recipe, but my measuring cups are dirty, so I want to weigh it instead. The side of the jar tells me that 2 tablespoons equals 33 grams, and I also remember that 1 cup equals 16 tablespoons. So first we want to identify, like I said, our given and our want. So if we look at our problem, I know that I need to add half a cup of peanut butter. So that's where I'm starting, with 0.5 cups. The other thing it tells me is that instead of measuring it, I want to weigh it. So we're going to try to find a weight. And in this case, because it tells us later, we want our weight in grams. So we're going to get and so I need to know what information I'm giving both with numbers and with units because both are going to become important. Now, my next step in doing a dimensional analysis problem is going to be setting up my tracks. And so these are the first part of my tracks. All this is this is going to tell us that anything that's next to each other gets multiplied, and anything that's on top of each other is going to get divided. So really all we're going to do here is mush a whole bunch of fractions together. And if you can remember how we work with fractions, dimensional analysis will be really, really easy. The very first thing I want to put in here is my given, which is 0.5 cups. My given will always, always, always go in my top left here. Underneath, you can leave it blank, but if that's going to worry you, you can also put a 1, because we know that anything over 1 is still the same thing. Now my next step is going to be to figure out what I need to add as my unit factor to cancel out the units I have right now. So right now I've got cups here on top. So if I want to get rid of it, it's just like if I had a 2 on top. If I want to get rid of a 2 on top, I have to put it down on the bottom. So I'm going to put cups down on the bottom. So we look through our problem, and we need to find some kind of unit conversion that involves cups. So if we read through, we have one unit conversion that involves cups, and that's 1 cup equals 16 tablespoons. So we're going to plug that in as our unit conversion. We're going to put a 1 with our cups, And then on top, we're going to put these 16 tablespoons it's equal to. It's always best to plug your units in first because then you know where your numbers should follow. So I can cancel out my cups and my cups. And if I were to stop my problem right now, I would be in tablespoons. Is tablespoons really what I'm looking for? No, because I want a weight. So I'm going to need another unit conversion. So we're going to add another vertical line. And so I just put tablespoons on top. So if I've got tablespoons on top, I'm also going to need tablespoons down on the bottom. And I read back through my problem, and I need another unit conversion that involves tablespoons. I already used that 16 tablespoons equal to cup, so I can't use that again. But then I do have that 2 tablespoons equals 33 grams. So we're going to use that. And we know that our 2 has to go with our tablespoons. And so the other side of this is going to be 33 grams. So if I work this out, because I've got tablespoons on top, tablespoons on bottom, those cancel out. If I were to do all my math right now, my units would be grams, and I want my weight in grams, so I've gotten where I need to be. So now the next step is to actually do the math. So try putting it in your calculator. Everything on top is going to get multiplied together. So we're going to have 0.5 times 16 times 33, because those are all on top together. And if I look down at the bottom, I've got a 1 and a 1, so I don't have to write those, but I also have a 2. So I'm going to divide by 2. And so we do the math. We plug it all in our calculator. We have 0.5 times 16 times 33 divided by 2. And that will work out to be 132. But I can't have a naked number because this is science. We don't have just have numbers hanging out. And if we look back at our problem, all that's left for units is grams. So you don't have to worry about figuring out your units. You just go with what's left over. All right. Now let's try another one. You might want to pause this for a second and try it on your own and then see if I work it out the same way. All right. So what we have here, I want to drive to New Orleans for Mardi Gras, which is 506 miles away. We looked it up on Google Maps. I need to know how much to budget for gas, because that tends to be a big expense in this sort of trip. I drive a Prius that averages 45 miles per gallon, and I'm estimating that gas will be an average of $2 per gallon for my trip. All right, so think about what was our first step? That was figuring out what we know. And if we look through, there is one thing we know, that we're trying to drive 506 miles but you may be thinking there's a whole bunch of other numbers. Generally, when you're trying to identify your given, you want the one that only has one unit. The other ones are miles per gallon and dollars per gallon, and we're going to have to deal with those in a second. It's always best to have something by itself for our first number. The other thing we need is what we want. And what we want here is how much to budget for gas. And so we're looking for the cost of that much gas. So this is a money problem. All right. Now we know we need to do what? Let's set up our tracks. We always want to make sure we leave ourselves some space because we're not sure how far we're going to need to go. So we always put our given in the exact same spot. Our given always goes up here in the top left. And if this is going to freak you out, remember to put a 1 underneath, because the 1 doesn't actually tell us anything. It just leaves us not having a gap there. All right, so since I have miles on top, I also need miles where? On the bottom. So I'm going to put miles down here, and I need to look through my problem and find something that involves miles and another unit. So I'm looking through, oh, my car gets 45 miles per gallon. And what we need to remember about per is it means we've got a fraction. So how this could really be written out as a unit conversion is 45 miles can be traveled for every 1 gallon of gas we use. But that's not the way we need it, is it? Because where are my miles? They're on the bottom. So I'm going to put my 45 with my miles, and then on top, that leaves me my 1 gallon. All right. So if I cancel out the units I've used so far, I have miles on top, I have miles on bottom, and I'm left with gallons, but I want money, and I'm not to money yet. So that means I'm going to need another unit conversion. So now I need a unit conversion that involves gallons. So I read through, and the only number I've got left is $2 per gallon. So we just said that if we've got per, we've got a fraction. And we know we need gallons on bottom. So $2 per gallon means that every 1 gallon is going to cost us $2. You're familiar with this one. If you've got a car, you've used this a lot. All right. So I have gallons on top, I have gallons on bottom, they cancel out. This leaves me with just dollars, and that was what I wanted. So I know I've got everything set up right. So now, remember, all our vertical lines mean multiply. Our horizontal line means divide. So we multiply everything on top. So we've got 506 times 2. We also have times 1, but that doesn't actually change our value. 506 times 2, and then on bottom, we've got 45. So we're going to divide by 45. So we plug that in our calculator. 506 times 2 divided by 45, and that's going to give us 22.49 dollars. So that is a reasonable estimate of what we need for our trip. All right, so now you're going to have to try some on your own. You'll have both some ones that just involve normal everyday units you're used to, and then a few that start getting into some special chemistry units. Work through, make sure you're writing out all of your parts. Under no circumstances should you try to do this in proportions instead of doing dimensional analysis. We'll be checking. If you've got any questions, let me know.